All right. So today's lesson is on factoring. We're going to start factoring. This whole unit is actually on solving quadratics. So we're going to start off with factoring. And today we're going to focus on finding a greatest common factor and then factor by grouping. And we're going to discuss the zero product property. So the first thing that I want to talk to you about is what exactly is a greatest common factor. So when you look at all the terms and you try to determine the greatest common factor, it's just going to be the largest number that divides all the terms. So that's what the number is, but you also need to think about your variables. So in terms of the variables, you want to pick the one that you're looking for the same variable and the lowest exponent. Same variable with the lowest power. My goodness. Same variable, but the lowest exponent. Okay. You're going to write out that greatest common factor, and then you're going to divide every term by that. So I have also printed times tables for you because I think that sometimes we forget all of the things that we can divide a number by. So if you were looking at your times table, you could find 35 and 42 in the same row of the sevens because 35 and 42 are both divisible by 7. So when I think about factoring this out, I'm going to take a 7 out. And what does that give me left? Well, 35x divided by 7 is 5x. And 42 divided by 7 is 6. So I have 7 times the quantity 5x plus 6. Now, how could you check this? Well, if you wanted to check it, you would just distribute, right? 7 times 5x, well, that's 35x. And 7 times 6, that's a positive 42. So if you've factored it right, if you've taken out the appropriate greatest common factor and you multiply back through, you're going to see that you get exactly what you had to begin with, okay? So this is the answer, and this is how you check it. All right, so let's look at our next example. So if I was looking at a times table, I would look and see what column can I find the numbers 18, 17, and 54 in, all of those terms. And when I do that, I can see that these are all divisible by the number 18. They're all divisible by the number 18. So I'm going to pull out the number 18. That comes out front. 18x squared divided by 18, well, that's x squared. 72x divided by 18, well, that's a positive 4x. And negative 54 divided by 18, well, that's a negative 3. Okay. All right. Now our next one has some variable terms. So the first thing that I'm going to look at is I'm going to figure out what the coefficient or the term, the number that I can take out of. And I see that 35 and 45 are both divisible by 5. So I'm going to take a 5 out. But now I want to look at the variable terms. So I have an x squared and I have an x cubed. So the smallest power of x that I have is an x squared. So I can also take out an x squared. And then I want to look at my powers of y. When I look at my powers of y, I see that the smallest power of y is a y squared. The smallest power of y is a y squared. So each term is going to be divided by 5x squared y squared. So now that makes you think about how you divide exponents, right? How do you divide exponents? Well, when you're dividing powers, right? You divide the constants or the coefficients. So 35 divided by 5 is 7. But when you think about x squared y cubed, that's what's left over right here, divided by x squared y squared. Well, here's the rule is that if they're exactly the same in the numerator and the denominator, those just cancel out. But if I have two different powers, a y cubed over a y squared, well, the rule is that you subtract the exponents. And I want to show you why. Y cubed is just y times y times y, and y squared is y times y. And when you cancel out, you're left with y to the first power. But if I use the rule is that I can subtract the exponents. Y to the 3 minus 2 power is y to the 1 power, which is exactly what I have there. So this is going to give me a 7y. And then I'm going to divide 45 by 5, and that's a positive 9. X cubed divided by x squared. Well, x cubed, x3 minus 2 is x to the first power, which is just an x. And then my y squareds cancel out. So my answer is 5x squared y squared times the quantity 7y plus 9x. Okay, let's look at example 4. So for example 4, I'm trying to find the largest column, like the farthest away from 0, right? Find the column that has all of these numbers in it. I'm looking for the number 24, the number 6, and the number 54. So my greatest common factor is a 6, number-wise. Now let's look at my powers. I have an m squared, an m squared, and an m squared. So I'm going to take an m squared out of everything. I have n to the first power, n to the second, n cubed. So the smallest power of n is just n to the first. So I'm going to take out an n to the first power. And then my p squared, let's see. I have a p squared, a p to the first power, and a p cubed. So the smallest power of p that I can take out is p to the first. So that means that I'm going to divide each term by 6m squared n p. Each term. Mrs. Bischoff. For okay, I didn't have that written down. Nope, that's okay. All right, thanks, hon. Bye bye.